Alright, now we're going to move on and talk about unit price. Isabella buys 4 pounds of tomatoes for $6. How much do 7 pounds of tomatoes cost, and how much do 10 pounds of tomatoes cost? So, for our first modelet, it says that you can use a table to help you find equivalent ratios. To do this, we have to use our ratio of 4 pounds of tomatoes that cost $6, and we're going to find our related rate. So if we divide both quantities in this ratio by 2, we can find that 2 pounds costs $3. So we're going to work our way down. Do that again, and you can divide both quantities of the ratio by 2, and you find that 1 pound costs $1.50. So $1.50 would be our unit price, or the price for the 1 unit, which we've talked about before. So we can fill in our chart based off that. If we know for every pound of tomatoes it costs $1.50, we can multiply our number of pounds by $1.50 to get our total cost. So let's go in and fill this chart. So like I said, we multiply the number of pounds by $1.50 to get our cost. So 2 times $1.50 would give us $3. 3 times $1.50 would give us $4.50. 4 times $1.50 gives us 6. 5 times $1.50 gives us $7.50. 6 times $1.50 gives us 9. 7 times $1.50 gives us $10.50. 8 times $1.50 gives us 12. 9 times $1.50 gives us $13.50. And 10 times $1.50 gives us $15. Okay, the second modelet, it says that you can add or multiply with numbers in the table to complete the rest of the table. Here's one way to find missing values. So basically they've taken, if we're looking for 3 pounds, if we're looking for 3 pounds, we can take the 2 pounds plus 1 pound, those costs, and we can add them together. So the cost for 2 pounds was $3, the cost for 1 pound was $1.50, so we add those, and 3 pounds would equal $4.50. And you could go through and do that with all of them. So for 5, they added 2 and 3 to get a total of $7.50. For 6, they multiplied 2 times 3, so we'd multiply $3, because that's how much for 2 pounds, times 3, and for 6 pounds, they got $9. And you can see how they went through on each one of these to get their totals. So we're going to use those previous 2 methods to work through some problems now. So on page 29, number 2 says, what ratio is given in the problem? Our original problem. Good, it's $6 to 4 pounds. Explain how to use this ratio to find the unit price. This is just like finding our unit rate. What would we do? We would divide by our second quantity. Which in this case would be 6 divided by 4. Number 4, how can you use the unit price to find the cost of 7 pounds of tomatoes and 10 pounds of tomatoes? Find the cost. Well, if we know how much 1 pound is, we can take that cost, which is $1.50, and we multiply it by the number of pounds. So $1.50 times 7 would give us $10.50. And then we would multiply $1.50 times 10 to find the cost of 10 pounds of tomatoes, and that would give us $15. Number 5, when might you make a table of equivalent ratios to solve a problem? When might you find the unit rate and multiply to solve the problem? Well, we'd probably want to use a table when we have to fill in several different equivalent ratios. If you're having to do one at a time, it will take you a lot longer to do the multiplication method than it will be to just fill in a table and work your way through. To find the unit rate then, unit rate and multiply is when you're doing just one or two. So, number 6 says, explain how you can find the amount of tomatoes that you can buy with $18. So, this time we have our money. So, we'd kind of be working backwards from what we have before. So, if we know how many or how much money, and we're trying to find out how many pounds, we can take our cost, which is $18, and we would divide it by the cost per pound. So we would take $18 divided by $1.50. So when we do that, we would get an answer of 12 pounds. You could also look at it like we did with the second model it, and you could take and combine your amounts of money. So we know that $15 is equal to 10 pounds, and we know that $3 is equal to 2 pounds. So if we added 15 plus 3, it gives us $18. And so we could then add 10 plus 2 to give us a total of the 12 pounds. Okay, now I want you to use what we just talked about up above about unit price and work out number 7 and number 8. Remember, pause the video, take a few moments, work them out, and then resume the video for the answers. Okay, for number 7, we're going to find our unit rate, and then we're going to multiply. So if it says Miss Cisneros bought 3 yards of ribbon for $1.50, how much would 5 yards of the same ribbon cost? Start with your ratio, $1.50 over 3. So then find your unit rate by dividing top and bottom by 3. You would get 50 cents for 1 yard. Then you would need to take your 50 cents and you would multiply it by 5 to get a total of $2.50. For number 8, you would follow a very similar process. We start with our unit rate. So it says Jack bought 4 bagels for $3. So set up our ratio, find your unit rate. So you would get 75 cents for 1 bagel. And then how many bagels can he buy for $4.50? This time, instead of multiplying, we'd want to divide to find out how many bagels he could get for this cost. So we'd do $4.50 divided by 75 cents. When you divide those out, you would find that you get an answer of 6 bagels.
All right, so now at the top of page 30, we're going to be talking about constant speed. Look at the first yellow box there. It says, Bill drove 200 miles in 4 hours. At this speed, how long will it take him to drive 300 miles? How long will it take him to drive 400 miles? So the very first model it, you can show the relationship between miles and hours using a double number line. And that is what they have provided there for you, is the double number line. So now as we look at the double number line, you can tell that the related rate is 50 to 1, which would be 50 miles in 1 hour. So that would mean that there are 100 miles that he can drive in 2 hours right here. So what is in between 2 and 4? Just the number between 2 and 4. That would be 3, right? And then the number between 100 and 200 is 150. So we can continue on. You can tell these are going up by 50s. 50 to 100 is a 50 jump. 100 to 150 is a 50 jump, so on and so forth. So we can fill that in. Be 250. Next would be 300. 300 plus 50 is 350. And then 350 plus 50 is 400. Then the hours are going up by single hours. So 1, 2, 3, 4. Obviously, you guys know this is going to be 5, 6, 7, and 8. And at the end of your number line, you should also have your related rate, which is 50 to 1. This should be equivalent. Over here, this should be equivalent. So to find that, what is 400 divided by 8? You should get 50. So that would mean that those are equivalent. So now as we continue, you know that in 4 hours, Bill travels 200 miles. I'm right here. The same vertical line is labeled with 200 miles in 4 hours. If you divide both quantities in this ratio by 2, you find that in 2 hours, he travels 100 miles. Divide both quantities in the ratio 100 to 2 by 2, and you find that in 1 hour, he travels 50 miles. Now we're looking at the next model it down below. Here is one way you can use the quantities labeled on the double number line to complete the rest of it. Fill in the blanks below and then finish labeling the number line. Well, this can get kind of confusing, but let's break this down and do this looking at these first, okay, and then look at the next. Okay, so those are equivalent, and then that's actually going to be to here, sorry, to there, and then from here to here will all be equivalent. So looking at it, you have 3 hours equals 2 hours plus 1 hour. And blank miles, how many miles is 100 plus 50? It's 150 miles. Okay? So now you know that we're comparing this to here. So 100 miles plus 150 miles goes in this blank. What is 100 plus 150? You should get 250 miles. Okay? Then 6 hours equals 2 hours, and this little dot right here is the same as a multiplication sign. So 6 hours equals 2 hours times 3. So 2 hours times 3 will give you 6 hours. And 100 miles times 3, there's that little dot again. 100 times 3 is 300. So the rate is 50 miles for each 1 hour. Bill can drive 50 times 7, or, well, what's 50 times 7? 350 miles in 7 hours, and 50 times 8 is 400 miles in 8 hours. Again, this is 150, this is 250, and the next one is 300. So if you don't have this, make sure you have this in your notes. All right, now at the top of page 31, look at number 9. What does the double number line show as the unit rate? If you look back over on page 30, what are you comparing to 1? How many miles to 1 hour? Hang on, let's go back. Okay, you should get 50. Okay, so 50 miles to 1 hour, that's the related rate, so your unit rate would be the number related to 1, which is 50. So show how to use the ratio given in the problem to find the unit rate. Well, the ratio in the problem was 200 to 4, right? 4 hours. 200 miles in 4 hours. So you'd have to do 200 divided by 4 to get 50 miles per hour. So now that we have that, number 11, how can you use the unit rate to solve the problem? Well, the original problem was, how long will it take Bill to drive 300 miles? And how long will it take him to drive 400 miles? And that's at the top of page 30. So, if we divide 300 miles, I'm going to put an M for miles, and 400 miles by what? You're always going to divide by your unit rate, which is 50, to find how many hours it will take to drive each distance. So you're going to get, if you do 300 divided by 50, that's going to give you how much? I'll give you a little bit of time to figure it out. Then you also need to do 400 divided by 50 and work that out. And you should get 6 hours, and then on the next one should get 8 hours. So then put these answers here on 11. Okay, so number 12. Suppose you want to know how long it will take Bill to drive 325 miles. How can you use the double number line to do this? Well, it gives you 300 and 350 on the double number line. And where does 325 fall? It falls right in the middle. So, halfway between 300 and 350 is 325. So you go down here to the hours, which this one would be 6, this would be 7. What falls right in between 6 and 7? 6.5. So you just explain that. 325 falls between 300 and 350 miles. So looking at their corresponding hours, 6.5 is between 6 and 7. So now number 13, I'm going to erase this. 13 says describe how you can use the unit rate to find how long it would take Bill to drive 325 miles. Again, unit rate is the real deal. Our unit rate was what? Up here. It's 50. How would we use the unit rate to find how long it would take him to drive 325 miles? If you do 325 divided by your unit rate, which is 50, you will get 6.5. So then you just explain that. Divide 325 by 50 and you get 6.5 hours. So looking at 14, how is solving a problem about constant speed similar to solving a problem about unit price? And how are these types of problems different? Well, you can solve these types of problems in the same way. So you can solve in the same way by using what? A double number line a table or the unit rate. The difference, okay, so now we're going to look at the difference. The difference is that unit price problems involve units of money, whereas constant speed problems involve units of time and distance. I'll give you a second to write that down. Now you need to try it at the bottom of page 31, 15 and 16. So do both 15 and 16, and then I will give you the answers for both. So pause the video and do 15 and 16.
Say if they don't understand reason.
Okay, to page 15, you should have gotten, hold up, you should have gotten 800 miles. Okay, if you do not understand how we got that, raise your hand and we'll come help you. And on 16, you should have got 5 hours. Again, if you don't understand, raise your hand and we will come and help.
Okay, so the last part we're going to go over is converting measurement units. So the problem says Tony is pouring milk for students' lunches. She knows that 3 quarts of milk contain 12 cups. How many cups can she pour with 7 quarts of milk? How many quarts does she need to pour 10 cups of milk? So on the first modelet, you can use the unit rate to make a table. So we know that the rate is 4 cups to 1 quart. The unit rate would be 4. So to figure this out, we would multiply each number of quarts by 4 to find the corresponding number of cups. So the table shows that 7 quarts is the same as 28 cups of milk.